Good afternoon, everybody. My name is Omid Mousavi. I'm R&D director at DEPsys. A statistic shows the percentage of world population interested in explaining electrical networks is negligible. I'm curious by a show of hand, which percent of the people here is interested in explaining electrical networks to others? So we are not negligible. Good. Everybody can use a different example to explain electrical networks. I'm going to use an analogy between electrical networks and a tree. The electrical network is built to transfer energy from the roots to the strong and stable trunk, which is transmission network with a lot of supervisory and control infrastructure, and distribute the energy through the branches, and then supply the end customers, which are the leaves, actually, of the tree. For us, the interesting part is the branches, where there is no infrastructure for monitoring and no information available about the security margin of this part. Moreover, nowadays, there are new trends for using these branches. The first trend is the increase of load by electrification of mobility and heating and cooling consumption. For example, for this branch, if we add more electrical vehicle, there will be more pressure. If we increase the electrical vehicles, the quality of the branch becomes lower. And even if we increase the electrical vehicles, the branch will break down. The second trend is the distributed energy productions. The impact is similar, but in the opposite direction. So it's very important to consider the physics of these branches and also know the situation of them. The situation is as following. The branches are geographically distributed everywhere. And the electricity flows in these branches based on physical laws which cannot be changed, unlike human laws. And the status of the network is that the network is operated blind, so there is no monitoring infrastructure there. Plus the fact that there are new trends in terms of using these branches and more expectations from them. Utilities are aware of this situation, and that's why they're looking for technologies for monitoring, control, and optimization of these branches. In DEPsys, we have met more than 250 distribution system operators across the globe, which has allowed us to observe different branches and understand their physical behaviors. Fortunately, physics is everywhere the same. And we could finally develop a product called GridEye, which is a combined hardware and software, which simultaneously is a powerful edge computing and also sophisticated head-end system, which provides a different large of applications for all the utilities across the globe. So GridEye primarily puts light on the dark branches and make them visible and provides insight for them. Then it enables then it provides information about the quality of these branches, plus controls them and make them stable. As a unique feature, we are able to identify the characteristics of these branches without having any information of the length or the size of the branches. So GridEye has allowed us to just want to remind you that all these applications we have provided to we can provide all these applications with one single hardware, and it's not multiple devices. At the moment, utilities are using different devices for each of these applications. So that's why we call GridEye the digital Swiss Army knife for distribution grids. Thanks to this multifunctionality and easy-to-use features of GridEye, we could expand our market internationally fast. Currently, we have 30 distribution system operators in 10 different countries in Europe and Asia as our customers. And we have reputable investors who has been following us since the beginning. And we will be happy to discuss with the other investors in the future. Thank you very much.